be real. This chapter on scientific measurements is probably not your most favorite topic so far. I get it. But we do need to learn it. We need to have a good foundation in it because we're going to apply it to a lot of chemistry problems, and it really helps shape our mindset. So y'all, let's power on through this. We have a couple topics left for this week. Time for a history lesson. So back when civilizations were getting started and humanity was building itself up, how did we know how much to give each other for different types of goods? Let's say we wanted to sell some wool from our sheep. Well, what unit of measurement do we use to compare for how much that wool is worth? That's where units come in handy. Units of measure. So a measurement is a value plus a unit. So you can think of the value like a number, and then the unit. A unit is any standard used for comparing measurements. Used for comparing measurements. Some examples of units that you're familiar with include the foot, which is a unit of length. We also commonly use pounds, which is a unit for weight. But all these units are a way for us to compare the value we're looking at. Units are so important because they're what allow us to compare values. Without that unit, we have no method of comparison. In the United States, we use units of measurement like feet and pounds for, like height and weight. But actually these American units are not what science uses. So let's talk about the units that science does use. The units that science uses have a specific name. So they are SI units. And SI stands for System International Units. Science uses these units so that we can compare data, across the United States, across countries, so that we have a common language to talk about our science. Let's draw a chart of these common units. So these are the SI base units. And I say base units because there are only a couple primary units in the system that just are, just straight up are what they are. A lot of other units actually are like mixtures of these base units coming together in different ways. So, in one column, we are going to have the quantity. So what the measurement is for. Then we are going to have the unit itself, and then the symbol. Because y'all know we don't like having to write out these words every single dang time. All right, so for length, instead of using the foot, our base unit is the meter. And the symbol we use is a little m. So for mass, We don't use pounds. We use kilograms. A lot of the times we will work with grams, or actually something smaller than grams, because a lot of the stuff we work with is not this much. The symbol for this is kg. So K for kilo, G for grams. Okay. Then we have temperature. We will talk about this more in depth later on in this lesson. But what you need to know now is that for temperature, the scientific unit is what is called the Kelvin. So the unit is the Kelvin, and the symbol is a capital K. We are familiar with Fahrenheit, so degrees Fahrenheit. Pretty much everywhere else in the world uses Celsius, degrees C. But in science, we actually use this, the Kelvin. And again, we'll get into more detail later of why and what that is. But we don't use Fahrenheit. So time. So we won't really work with time much in this class, but I want y'all to see that the SI unit for time is the second, which the symbol is S. And the last main one is amount of substance. Amount of substance. This is distinctly different than mass. And we'll get into more on this later, but for now I want you to know that there are a couple of base units that we need to know. We need to be familiar with these and their symbols. So the amount of substance, the unit is called the mole, M-O-L-E. If you've never heard of this before, it's okay. It's kind of funny sounding. Like, whew, why would you name it a mole, right? This is so super important to chemistry, though. So super duper important. And again, we'll get into this later. The symbol is, it's not super convenient because it doesn't super condense the word. But I was not there when they decided this. The symbol is MOL. So just one letter off. Y'all, you need to know this chart. You need to know this chart. There is no getting around it. There is no, you need to know this chart. You need to be familiar with it. You need to know the symbols. Know this chart. I want to point out something pretty interesting about the SI units and why we use them as opposed to like the American units. So American units don't have a lot of pattern to them, don't have a lot of rhyme or reason, as opposed to the fact that they were convenient at the time. So think of a foot. That came about as a unit of measure because we have feet, like human feet, and could use that as a unit of measurement. But y'all, like, conversions among American units is not super intuitive, whereas SI units, they're based on multiples of 10. So that's a lot easier than the randomness of American units. So that's why, that's a good reason why we use these, because they're easier to work with. Again, these units allow us to make comparisons. So for example, which of my two dogs is faster when they run? We're comparing the seconds. Which of them is heavier? We're comparing the mass. These units are so important, y'all, and this is why I always stress, put your units on everything. All measurements use a base unit or a combination of them. So, for example, we saw that length is in meters. But what about something like speed, right? Or like velocity? So if you go on to take physics, you'll learn more about velocity. Velocity is meters per second. So m/s. So we see that here, length is straight up just one of the base units, but velocity is a combination of them. So all the measurements we take, all of them, are just some combination of the base units. And this is actually really important because if you're trying to solve a problem and, well, you start with one unit, but you need to get to a different unit, how can you use a combo of them to cancel out the ones you don't want? We'll actually get into that a little bit later. Additionally, sometimes we work with very big or small numbers. Just like we looked at that example of, the the width of the universe, we don't want to write that all out every time. We can actually use a combination of prefixes plus a base unit to write out these bigger small numbers in a more convenient way. You do not need to write this table down. This is a table of common prefixes with the SI units. We are going to focus in a minute on the 3 most common ones. What I'm showing you here is that there are multiple prefixes to indicate how large or how small the order of magnitude that a value is. You stick the prefixes in front of the unit. So for example, you've probably heard of centimeters before, or millimeters, or kilometers. Let's look at those. Let's write out a table of the 3 most common prefixes you will encounter in this class. You need to know these. You need to know them. You need to know how to use them. You need to know the symbol. Know this table. So we have the prefix, the symbol, because we don't like writing out the whole word every time, and we have the factor. So by factor, I mean the bigness or smallness, the magnitude. Those were not straight lines. They're slanted. Okay, so the first one we're going to look at is kilo. So you might have heard of kilogram or kilometer. So the symbol is little k. The factor is 10 to the third. Another way to write 10 to the third is 1,000. So kilo means 1,000 in terms of bigness, in terms of the magnitude. The next one we'll look at is centi. So centi, like centimeter. The symbol is little c. The factor here, so centi refers to a small number. So the factor is 10 to the minus 2. We can rewrite this as 0.01. Another way to think about centi is that it is 1 over 100. I think this is easier to look at, the fraction form, because I can easily say, yes, kilo is 1,000 times, but centi is 1/100th, so it's smaller. The last one we need to know is milli. So you might have heard of like millimeter, or even if you think of a millipede, like the little insecty thing. The symbol for milli is little m, and the factor for milli is 10 to the minus 3, which we can also think of as 0.001, or what I think makes more sense in my brain is to say, this is 1 over 1,000. So again, kilos for big stuff, centi and milli is for little stuff. How do we use the prefixes to actually write a measurement out? So the way you use prefixes is you have your prefix plus your base unit. Let's look at some examples. $1,000 meters is 1,000 times bigger than 1 meter. So we can write this as 1 kilometer. Remember, K, kilo, 1,000, kilometer. There we go. Kilometer. Let's spell that out. What about if we have 0.01 meters? So this is 1/100th of a meter. So this is 1 centimeter. So you're going to see how I put the prefix with the base unit here. Let's say we have 0.001 seconds. So this is 1,000th of a second. So here we're looking at 1 millisecond. So millisecond. All right. At this point, I recommend that you look over your notes, take maybe a quick little break, and then work on the next part in the problem set.